Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah sallallahu alaihi wasallam. Our lesson today, we are talking about Euclidean theorem. We know, we studied before Pythagoras. Pythagoras theorem, if we have the length of two sides in right angle triangle, we can find the length of third sides by Pythagoras theorem. If we have the ABC right angle triangle, if we want to find the length of the hypotenuse, the length of the hypotenuse equal the square root of the square of the length of two sides. Here, Euclidean, in right angle triangle, and from the right vertex we draw the perpendicular to the hypotenuse. If ABC is right angle triangle at A, from A we draw AD perpendicular to BC. We know the area of square equal side bar 2. Area of rectangle equal length by width. In the triangle ABC, right angled at A, then in Pythagoras we know BC power 2 equal AB power 2 plus AC power 2. And AC power 2 equal BC power 2 minus AB power 2. Here, Euclidean, in right angle triangle, we draw perpendicular from right angle to the hypotenuse. If we wanted to find the square drawn on any sides of right angle, on AC or AB, we know area of square equal side bar 2, and the area of rectangle equal length by width. In Euclidean, he told us the area of a square drawn on the side of the two sides of right angle equal the area of rectangle. We know rectangle has two dimensions, length and width. Area of a square drawn on one side of the two sides of right angle equal area of rectangle of the two dimensions, the projection of this side and the hypotenuse. So it's mean AB power 2 equal the projection of AB on BC is DB and the hypotenuse is BC. Then we can find AB power 2 equal BD time BC. AC power 2 equal CD time CB. In right angle triangle, the area of a square on the side of the right angle, it's mean AB or AC, is equal to the area of the rectangle whose the dimensions are the length of the projection of these sides on the hypotenuse and the length of the hypotenuse. It's mean AB power 2 equal, catch the point belong to the hypotenuse, AB power 2 equal BD time BC. AC power 2 equal, catch C, CD time, excellent, CB. What about AD? AD power 2 equal, catch D because D is a belong to BC. AD power 2 equal DB time DC. AB power 2 equal BD time BC. AC power 2 CD time CB. What about AD power 2? AD power 2 equal DB time DC. We can find the length of AD by another rule. We know area of triangle equal half time base time height. In the triangle ABC, here we have the base BD and the height AD. Then we can find the area of triangle equal half time BC time AD. Or we can use the base AB and the height equal AC. Then the area equal half time AB time AC. Then the product of two sides of right angle equal the length of the hypotenuse times the length of perpendicular from the right vertex. So BC time AD equal AB time AC. So we can find the length of AD equal AB time AC over BC. We can find AD by AD power 2 equal DB time DC. Or AD equal AB time AC divided by BC. In the opposite figure complete, AC power 2 equal space plus, here plus or minus we use Pythagoras theorem. Plus its mean AC is the hypotenuse. AC power 2 equal space plus or minus its mean use Pythagoras theorem. Plus its mean AC is the hypotenuse. So we look at the triangle A D C. Here AC is the hypotenuse. So we can find the AC power 2 equal X and AD power 2 plus DC power 2. Number 2, AC power 2 equal space minus its mean use Pythagoras theorem. But here AC is side. So we use the triangle ABC. Measure of angle A equal 90 degree. BC is the hypotenuse. Then AC power 2 equal BC power 2 minus AB power 2. What about number 3? Number 3, AC power 2 equal space time. Here time its mean use Euclidean theorem. Catches the point belong to the hypotenuse C. Then AC power 2 equal catch C equal CD times CB. Number 4, AD power 2 catch the point belong to the hypotenuse D. AD power 2 equal DB times DC. AC times AB equal AB times AC. It's a product of two perpendicular sides equal the product of two perpendicular sides CB times AD. In the opposite figure, XYZ is the right angle triangle at X. XL perpendicular to YZ. L belong to YZ. YL equal 9. LZ equal 16. Find the length of XY. Find the length of XY. Here, X, Y, Z right angled at X. And from the right vertex, we draw the perpendicular to the hypotenuse. Then, XY power 2 equal YL times YZ. YX power 2 equal catch Y, YL times YZ. Here YL equal 9. YZ equal 9 plus 16 equal 20 equal 9 plus 16 equal 25. Then XY power 2 equal 9 times 25 equal 225. Then we can find XY equal square root of 225 equals 15. Number 2, find the length of XZ. XZ catch the point belong to the hypotenuse. Z. Then xz power 2 equal zl times zy. zl 16, zy 16 plus 9 equal 25. Then xz power 2 equal 16 times 25 equal 400. Then xz equal square root of 400 equal 20 centimeter. What about xl? Here we can use Euclidean xl power 2, catch l equal ly time lz equal 6 time 16 time 9 equal 144. Then xl equal 12. We can find the length of xl by another way. In right angle triangle xly, we know the length of ly and the length of xy. So we can find xl power 2 equal xy 15 equal 15 power 2 minus 9 power 2 equal 144. So we can find xl equal 12 centimeters. Or in the right angle triangle xlz, it will be xz power 2 minus zl power 2. Or we can find the xl as the form, the product of two perpendicular sides, xy times xz over the length of the hypotenuse over 25. It will be 12 centimeter. ABC is the right angle, the triangle at B. D belong to AC and BD perpendicular to AC. Here, from right angle, we draw the perpendicular to the hypotenuse. Find the length of AC. In right angle, the triangle ABC, we know the length of AB and BC. So AC power 2 equal AB power 2 plus BC power 2 by Pythagoras. AC power 2 equal AB power 2, 8 power 2 plus BC power 2, 6 power 2, 2 will be equal 100. Then we can find the length of AC equal square root of 100 equal 10 centimeters. BD, we know BD equal BC times AB over AC. BD equal the product of two sides of right angle over the length of the hypotenuse. Then BD equal 6 times 8 over 10 equal 4.8. This is number 1. Number 3, the length of the projection of BD on AC. First, to find the projection of BC on AC. The projection of BC, the projection of B is D, and the projection of C itself. So he wanted to find the length of DC. The projection of BC on AC is DC. Then he wants to find the length of DC. Here we know the length of BD and we know the length of BC. So we can find CD from the triangle DBC by Pythagoras. It will be CD power 2 equal CB power 2 minus BD power 2. But here I wanted to use Euclidean theorem. So we must put DC in the rule of Euclidean. We know BC power 2 equal CD times CA. BC equals 6. Then 36 equals CD times CA equals 10. we can find CD equals 36 divided by 10 equals 3.6. Number 2, find the length of projection of AB on AC. The projection of AB on AC, projection of A itself, projection of B is D. Then he wanted to find the length of AD. First, we know the length of AC and we know the length of CD. If we subtract, then AD equal 10 minus 3.6 equal 4 equal 6.4. Or by using Pythagoras, we know the length of AB and we know the length of BD. We can find the length of AD as the form AD power 2 equal 8 power 2 minus 4.8 power 2, and then we find the square root. But here I wanted to use Euclidean theorem. AD, we want to put AD in the rule. AD. What about AB power 2? AB power 2 catch A equal AD times AC. AB 8. Then 64 equal AD times 10. Then AD equals 6.4. Or we can use another rule. BD power 2 equal DC times DA. Or subtract 3.6 from 10. It will be 10 minus 3.6 equal 6.4. ABC is a quadrilateral. Measure of angle BCD equal measure of angle BAD equal 90 degree. AA perpendicular to BD, BC 7, CD 24, AB 15. Number 1, find the length of each of BD and AD. Find the length of BD and AD. First, look at the triangle BCD. The triangle BCD. Measure of angle C equal 90 degree. And here we know the length of two sides. If we want to find the length of side in rectangle triangle, and we know the length of other two sides, then we can use Pythagoras. Then we can find BD as a form BD power 2 equal BC power 2 plus CD power 2. BD power 2 equal 7 power 2 plus 24 power 2 equal 625. Then we can find the length of BD by square root of 625 equal 25. What about AD? Look at the triangle ABD. Measure of angle A equal 90 degree. And we know the length of AB and the length of BD. We can use Pythagoras. AD power 2 is side. Then AD power 2 equal BD power 2 minus AB power 2. Then AD power 2 equal 625 minus 225 equal 400. Then the length of AD equal square root of 400 equal 20 centimeters. Number 2, find the length of projection of AD of AB on BD. The projection of AB on BD, the projection of AB is EB. Then he wants to find the length of EB. We know AB power 2 equal BE times BD. AB 15, then 225 equal BE times 25. Then we'll find the length of BE equal 225 divided by 25 equal 9 centimeters. Thank you and goodbye.